Welcome back. Let me show you something cool before we talk theory. Imagine you are designing a high throughput system on AWS. You want to stream 200k events per second into your platform, like logs, clickstreams, IoT, or whatever. I'm going to ask an AI model a simple question, that is, choose the optimal data ingestion pipeline for streaming 200k events per second into AWS. And I'll show you two very different ways to make the model think. First is chain of thought. Let's see what it is. And then tree of thought. First, look at what we got from CoT, chain of thought. So you can see that there are steps, which is the step 1 to determine the data format, step 2, step 3, step 4, step 5, and then a final answer, which is one recommended pipeline. So you can see that it reasoned in a straight line, and it listed the factors like partitioning, scaling, monitoring, and then it ended up with one recommended architecture, which is source, Kinesis data stream, and then target storage systems. So this is chain of thought. The model writes down its reasoning steps in a single path from problem to answer. Let's look at the second output. Straight away, you can see that the structure is completely different. It doesn't start with step 1 or step 2. It starts with the option 1, option 2, option 3. So instead of single reasoning path, the model is exploring multiple candidate solutions. So in the option 1, it says you can have Amazon data firehose. The second option is Kinesis data stream, and third option is MSK. And it also lists the pros and cons of each approach. And it's also giving score to each option. So this approach is called tree of thought. You can see that it's not just saying that Firehose is good or MSK is good. Based on the analysis, there is a selection section which says that it would recommend option 2, and it reasons it based on various analysis and descriptions and scores. And there is a final recommendation section which gives you a production ready solution. So what we got from thought, which is tree of thought, is multiple solutions, pros and cons per option, a scoring system, an explicit justified choice, and a final architecture write-up. If you show this to a stakeholder, it looks like a mini design document that's already done the trade-off analysis. Alright, now you have seen the difference side by side. Let's take a step back and talk about what we just saw. We asked the exact same question to the same model, and we changed the pattern of the prompt, and suddenly the model behaved like two completely different type of architects. That's not an accident. What you just saw are the two most powerful reasoning frameworks in modern AI: chain of thought and tree of thought. Chain of thought prompting is a technique that prompts a LLM to explain its reasoning process step by step before giving a final answer. Whereas tree of thought prompting is an advanced framework that enhances LLM problem solving and reasoning capabilities by allowing it to explore and evaluate multiple reasoning paths simultaneously. By the way, even though I showed a quick sneak peek of tree of thought at the beginning, we are not going to cover tree of thought in this video. It's a big topic on its own and deserves its own episode. So I'll break it down properly in the next video. Let's start with chain of thought. In 2022, Jason V and the team released the breakthrough paper, Chain of Thought Prompting Elicits Reasoning in Large Language Models. The researchers showed that on grade school math, accuracy jumped from 18% to 58% purely by prompting the model to reason step by step. On the left, with standard prompting, the model jumps straight to an answer. It looks confident, but in the research paper, they show that this approach often leads to incorrect results because the model is forced to guess without any reasoning. On the right-hand side is chain of thought prompting. In the paper, they demonstrate that when you simply ask the question and ask the model to think step by step, something dramatic happens. The model breaks down the problem, writes out intermediate reasoning, and the accuracy increases by a huge margin. The figure in the paper is a perfect example. The standard prompt incorrectly outputs 27, but the chain of thought, the model accurately explains the steps and arrives at 9. So the key takeaway from this research paper is when a model explains its thinking, it reasons better. CoT dramatically improves performance on math, logic, and multi-step problems. Now, different use cases require different CoT techniques. Here are the main variants. So we start with zero-shot CoT. Zero-shot CoT is the simplest version. It asks the model to think step by step and explain its reasoning. This is the exact technique that we just saw in the research paper. It makes the model slow down, write out its reasoning, and avoid guessing. Let's look at the Python example to see how zero-shot CoT works. So inside the function, you can see that we build a prompt that includes the question and an instruction to think step by step. Now watch what happens when we run it. You can see that it identifies the input and then it breaks them down into the steps, compute intermediate results, then finally gives a final answer. This is exactly what original Google CoT paper mentioned. Just adding a small phrase like think step by step dramatically increases accuracy. Few-shot CoT, which is even more powerful. This technique teaches the model the style of reasoning you want. Think of it like tutoring. If you show someone 2 solved problems, they can solve the third one more reliably. So this is what it is. Let's see a Python example to see how. You can see the function injects 2 working examples here. Then we append the real question at the bottom. And now let's run this. You can see that the model mimics the structure of the examples step by step and returns a final answer. Few-shot CoT is especially good for calculations, cost estimation, structured analysis, enforcing a format. In production system, this is often the most reliable CoT variation. But what if you don't want to manually write examples like this? That's where automatic CoT comes in. Let's take a look at it. Automatic CoT or Auto-CoT is where things get exciting. Instead of writing examples yourself, you let the model generate them. It creates few example problems. It solves them step by step. Then it solves your actual question using the same reasoning pattern. So let's inspect the code. You can see that the system prompt here literally asks the model to invent 2 examples, solve them first before solving the actual question. So let's run it. So this is the answer. Let's see. So you can see that the model has created 2 problem example. This is the first problem and it solved that, and there is a second problem, and then shows the full reasoning for each example, each problem it has invented, and then comes our actual question and then solve the actual question in the same pattern. So now we understand how chain of thought works. Let's talk about one of the most powerful upgrades to it, called self-consistency CoT. Here's the problem researchers discovered. Sometimes a single reasoning chain is wrong, not because the model is bad, but because it picked up a wrong reasoning path. So instead of forcing the model into one chain of thought, self-consistency lets the model generate multiple reasoning paths. Think of it like a brainstorming session. The model produces reasoning path A, B, C, etc. Each path ends with the final answer. Then, just like humans do, we take a majority vote, and something magical happens that the noise cancels out, wrong reasoning paths get outvoted, and the most stable and correct answer rises to the top. So this is straight from Google research paper titled Self-Consistency Improve Chain of Thought Reasoning in Language Models. It shows massive improvement on maths, logical, symbolical reasoning, and multi-step inference tasks. So the reason is simple. One chain of thought could be a guess, but many chain of thoughts create convergence. So self-consistency CoT is like asking 20 experts instead of 1. Okay, so let's look at the self-consistency CoT example. So here we have a small helper function. All it does is search the model's output for the phrase final answer and grab whatever comes after that. So that's what it is doing. So now look at the function itself. So this function works by sampling the model output multiple times. Each time it calls zero-shot function that we saw in the previous example, and because every time you call it, it will produce a slightly different reasoning chain. So we set the sampling rate to 5, which means we get 5 independent chain of thoughts. This mirrors the method used in the Google paper we just saw. They sample many reasoning paths because the model may reason differently each time. So that's what we are doing here. And then we are calling our helper function to extract the final result. We use Python's counter to literally count how many times each unique answer appeared. Then we pick up the best answer. If there are 3 out of 5 paths that say use Kinesis firehose, then Kinesis firehose becomes the majority answer, and this turns the noisy output into stable and reliable results. So this is the output format that we are going to print, and which result the original question, the traces, the extracted answers, the vote counts, etc. So let's run this function. So you can see there is a lot of output here, but the main thing to focus on is the final result, the majority answer, which says the optimal data ingestion pipeline for streaming 200k events per second into AWS is AWS Kinesis data firehose, and it also returns the majority result votes. So this is how the self-consistency CoT works. Next is structured CoT. It's where you give the model a reasoning template instead of letting it freestyle. This is especially good in engineering, law, medicine, where reasoning must follow a specific format. Instead of just saying think step by step, we are saying the model exactly how to think step by step. So let's see it in action. So I have created a system prompt where I tell the model that you are a principal level systems and a cloud architect, and these are the instructions to follow. Then I create a prompt with the question, and I ask it to follow this template, that where there would be a problem summary, requirements, a section for constraints and assumptions, and so on. So let's look at the output here. You can see that based on your template, it has produced each section. First we got the problem summary, then requirements section, then constraint and assumptions, and so on. In the candidate options, we have various options inside. Then in the end, it has recommended options and implementation plan. So that's the essence of chain of thought, getting models to reveal their reasoning instead of guessing. So zero-shot CoT gives us instant step-by-step thinking. Few-shot CoT teaches the model a reasoning pattern. Self-consistency CoT boosts accuracy by voting across multiple reasoning paths. And structured CoT lets us enforce real engineering frameworks. That wraps up our deep dive into chain of thought. In the next video, we take it even further with tree of thought, a reasoning system that explores multiple solutions instead of just one. Don't miss that one. If you found this useful, please like the video and subscribe to the channel. See you in the next video.